and sharing my, whoops, that didn't work. And, every once in a while, this touch screen, my fingers are too clumsy and the wrong button gets hit. Start sharing my screen. Today is February 10th. Can you believe it's that late in the year already? Wow. Um, we're going to start looking at probability. Before we start looking at probability, I don't want to spend a lot of time on it, but if anybody has any last minute questions, I'd like to deal with them. You're going to find that the SAT test is in My Labs. It will be available today at after class time. I think it's first available at 11, and you have 75 minutes to do it. And you can take it anytime before 11:59 at night on tomorrow. Project is due the 15th, which is Monday, but I'm looking at this and I'm going to put an asterisk there because I just realized that Monday is a holiday. And so we don't have class on Monday or Tuesday. So as I'm thinking about it, should I be a pushover and say, if you want to, we'll push that due date back till Wednesday when we have class, so that if anybody has any last minute questions on their projects before they turn it in, they can submit it on Wednesday. However, I would really, 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 really appreciate, oh, I can't believe I just thought of this. I would really, really appreciate it if you did submit it by Monday, so that if you submit it by Monday, the 15th, you'll get some extra credit. How's that sound? Rob, you got to get it
That's
done
good.
at a time when it makes it easier for me to grade them. So plus I gave you like 10, there should be more than sufficient time. Homework 6 is what we're working on today, and homework 7 will be what we're looking at on Friday. Both of those will be due on the 17th. We're going to start looking at counting methods. But again, before we start looking at counting methods, I want to go here and let you see that exam 1 sets is in My Labs, but notice that it's not going to be available for you guys until 11 o'clock. It should show up because this check mark is marked. If it does not show up at 11 o'clock, send me an angry email, although I won't get to it until closer to noon because I have another class right at 11. Also, if I go into, whoops, wrong way. If I go into Blackboard, in Blackboard, in learning modules and content, in tests and quizzes, there is a place for you to submit your work for the test. And again, if you open this on your phone, when you go browse my computer, it gives you an option to just open the camera up and take pictures. If you must take pictures, upload pictures of your work. I know in some of my other classes, people were telling me rather than using a camera and taking pictures, they like to scan the papers in, which is perfectly fine, and attach them through their computer, which is perfectly fine. If, however, you attach your work, if it does not open, I will send you an email and ask you to get it to me another way. But you, again, must submit your work or you will not get credit. Before we forge ahead and start looking at those, that next unit probability, does anybody have any questions on anything at all to do with sets? The project, the review for the test, any of the homework questions? I do believe that most of the test questions are similar to what was on that handout, but they are, because they're in My Labs, they're kind of more formatted like some of those homework questions. So your home, reading over your homework again is a good preparation. Does everybody know how to, in My Labs, if you go into the grade book, if there is, yeah, I have an assignment that I did. I can click on that assignment and I can go over and review my homework. It won't change my grade at all, but I can go through and look at more homework questions as practice. And again, I think I might have shown you this before, but if you go into the multimedia library and you pick on the chapter and you pick on the textbook, when you click on any one of the sections, a good place that you can go. We did this last class, right? I showed you where the chapter summary and chapter review is. Does anybody want me to carry on showing you that again, or are you all good?
You can show us again.
Okay, so up here in the upper left-hand corner, there's something that I can click on and it pulls down a menu. And then in that menu, you see there's a place, chapter summary, review and test.
Where did you click to show that menu on the left?
Okay, I'll exit out and do it again. Do you see up here? Let's see if I can. I'm trying hard to be multi-dimensional. Do you see this icon that I'm circling up in the corner?
Oh, okay.
Okay, and so if I click on that,
Anywhere in that circle.
if I click on that, then down here I can click on chapter summary, review and test. And so it starts with the summary, which is a good overview of everything that we did in the chapter. It would be, if I were to put together like a cheat sheet for you to study from, I would print out this chapter summary for you. And then there's review exercises, excuse me, and in addition to the review exercises, there is what Mr. Blitzer would give as a test, that another practice test.
Should
And
we
as you
review
go-
the 2.2, right? That's the one we should review?
Just chapter 2, all of chapter 2.
Okay.
And as you're looking at the chapter 2 review and chapter 2 test, if you want to take those on your own, down here at the bottom, does everybody see? I will try to pull my pen out again. Answers to selected exercises. All of the answers to the chapter review should be in there, as well as all of the answers to the the chapter test. So you can check to see if you did going there. Okay.
Okay.
So I don't know if that's interesting or not, but if you want to practice a little bit more before you take the test, that would be a place to go through and review things and practice. But
So
again,
review all,
Office
review all
I
chapters,
got
right?
class. I can't leave. Tell them I'm busy during class. Oh, sorry.
You recommend we review all chapter 2, right?
yeah, all of chapter 2, because the
Okay.
test is on all of chapter 2. And again, well, if I were giving a pencil and paper test, the pencil and paper test would be very much like that review that we went over last class. And I know we didn't quite finish it last class, but again, if you go into Blackboard, in Blackboard, if you go to the learning modules content, hopefully everybody's aware in that notes section, Unit 1 sets, today's notes will be in Unit 2 probability. For each class, there is a YouTube recording, but there's also the one that doesn't say YouTube are just the written words of the notes that we took. And so I did finish going through and filling in the answers to those last questions that we didn't get to last time, if you tried them on your own and wanted to check them. Okay. Does anybody want to look at anything more sets, or are we ready to forge ahead?
Sorry, I don't know if we have time since we just did that whole review thing, but I couldn't wrap my head around a couple questions on the homework,
Okay.
and they're kind of big questions, I feel like. So I was wondering if maybe
Questions, tell me which assignment and which questions.
the previous homework, like 5.2.5.
Okay, homework 5, which ones?
Question 10 and 11, I don't understand that well.
Okay. Let's look at the both of them. I think they're probably, are they similar questions?
Yeah.
So let's look at 10 and 11. Okay. The number 10 is very much like that one that we did in the Venn diagram handout. So let's go and let's look at number 11, okay? When I do a question like number 11, and I'm going to take this and, well, can you guys read that or do you need it bigger?
It's fine.
When I look at a question like number 11, I cannot do that without drawing and working with a Venn diagram. So they have a Venn diagram there, but when I made the font larger, I lost it. So here's A, here's B, here's C, and they had on them the Roman numerals 1, 2, 3, 4, 5, 6, 7, and 8. And you know how we had said that whenever we fill in a Venn diagram, we want to start in the center. And so the center, is everybody all right? That would be where all three overlap. So that is A intersect B intersect C. And so in that region, my cardinality is 8. Then from there, I'm going to work my way out. The next information that I have is B intersect C. B intersect C is this entire region. And as I look at this entire region, does everybody see there are 8 in it already? So if that entire region is supposed to contain 16, well, I'm going to take that 16 and subtract the 8 that's in there already. And that gives me 8 in this region. Are you comfortable with why I subtracted that 8 out?
So it's not like doubled kind of in there?
Right. So that whole area has to add up to 16. Okay. Now this next one tells me that A intersects C, and just because I'm having fun playing, I'm going to change colors. A intersect C is this entire region, right? The green region here. And A intersect C, that whole region is supposed to contain 10. But you see how there are 8 in there already? So if the whole thing's supposed to contain 10, and there are 8 in there already, I'm going to put 2 more in this region. So now that the green section adds up to 8 plus 2 or 10. In the same way, A intersect B is 16. A intersect, 16. A intersect B is this whole petal shape. And again, it includes that 8 common to all of them. And so I'm going to have to take the 16 minus the 8 that are in there already. And this region over here contains 8. With me so far?
Yes.
Yeah.
So then we know that, I'm going to go back to red. All of C is supposed to be 13. But wait a minute, there's some numbers in C already, right? If I add those, 2 plus 8 plus 8, there are 18 in C already. But that region's supposed to add up to 23. So if I subtract the 18 that are in there already, does everybody see I need 5 more to fill in C?
Yeah.
And then B, I guess I'm going to make B the brown. All of B is supposed to contain 28. Inside B, I've got 8 plus 8 plus 8, which is 24. If it total is 28, I need 4 more in B. So A, the total of A is supposed to be 23. Inside A already I have 2 plus 8 is 10 plus 8 is 18. So when I take that 23 minus the 18, I need 5 more here.
Okay.
But I'm not done yet. The whole gosh darn thing is supposed to add up to 41. Let's see, what do I have so far? 5 plus 8 is 13 plus 4 is 17 plus 2 is 19 plus 8 is 27 plus 8 is 35 plus 5 is 40. And so in order to get 41, I need one more. And I have to fill them in that order. I can't just look at that information and say, oh, I know how many there are in region 1. I've got to do my work first. But now that I have my work done, I know that region 1 contains, this isn't going to work well, guys, because this keyboard is annoying. But region 1 contains 5. Region 2 contains 8. And so from there, you see, now I can fill in the regions in a row because I filled my Venn diagram from the middle out to get it. Better?
Yes, thank you.
You're welcome.
We should always start from the right to left, right?
No, we should always, in terms of filling in or in terms of.
When you were figuring out the numbers that go into the regions, you started from the right and went all the way to the left.
When I fill them in, I start, whoa, did you see that swirl around? I start in the center and then I kind of work out. I do those 3, working out from the center, and then I do those 3. In terms of whether you go right to left or left to right, it doesn't matter. But what's important is you do this middle one first. And then after you do that middle one, the next ones you should do are the 3 overlaps. And with those 3 overlaps, it doesn't really matter which of the 3 you do first.
Mhm.
I have a tendency, because I've taught from this book several times, I have a tendency to say, okay, the middle is almost always going to be the last piece of information. And so I kind of take the information that I'm given and I work backwards. That's how I decide what I do next.
Now, the thing is, if you put the numbers in the wrong regions, then the rest of the problem will be wrong.
Right. Which is why there's the one on the test isn't like this with union and intersection, but rather it's like those survey questions. And so with the survey questions, when you draw your Venn diagram, if you show me your Venn diagram and you show me the work that you did with your Venn diagram, if one of those numbers was wrong, all of the other numbers will be wrong and all your answers in my labs will be wrong. But if I can follow the reasoning that you did on your diagram, and I just see that you made one careless mistake, I will give you, and all of your other answers are right for the Venn diagram that you drew, I will give you partial credit. In other words, those survey questions are a pain in the ass to grade because if we made one arithmetic error early on, every other answer is wrong.
Yeah.
But if I can tell that your reasoning was right for all of the numbers except for that one answer, or if I can tell, even if your whole Venn diagram is a mess, if your answers are correct for your Venn diagram, I will give you at least half credit. Which is why it's so important for you to do the pencil and paper work to submit it and to share it with me, please. Okay?
Okay.
All right. Anything else that anybody wants to look at from homework wise?
If we have still some time, would you mind going over 18 as well?
Sure.
Thank you.
I got to clear that. Turn my finger back into a mouse. Go up here, pull down this menu. It will eventually come in. And let's look at what 18 is. All right. It does not like me using my finger to get there. Let's try this again. Sometimes when I have it stretched out, it doesn't acknowledge that I touched it, which is weird. So it says a survey of college students was taken to determine the behaviors regarding alcohol, cigarettes, and illegal drugs. The results were so many drank alcohol, so many smoked cigarettes, so many used drugs, So many did alcohol and cigarettes. So many had alcohol and drugs. So many used cigarettes and drugs, and so many did all three, and so many did none of them. So again, like the preceding ones, this one you can't do without a Venn diagram. This Venn diagram, we have to fill it in before we can answer the questions. I'm going to label them for drugs. No, the first one was alcohol, right? So I'll call this one alcohol. This one I'll call cigarettes. And this one I'll call drugs. And then I don't want to take the time to fill in the whole Venn diagram, but okay, 234 did none of them. So that 234 that did none of them would be out here, right? And then 86 did all three. Where's that 86 going to go?
And in between, like the IV one.
In the middle, right?
Mhm.
Then 109 did cigarettes and drugs. Okay, so cigarettes and drugs is here. Should I just put the 109 here?
No.
No, what do I need to do with that 109?
Would you subtract it from 86 or
Yeah.
109 minus 86?
We will subtract 109 minus 86. And so that gives me, I think, 23 here. And similarly, alcohol and drugs, that's this. So over here, I'm not going to put the 106. I'm going to subtract the 86 from the 106 and put 20. And are you all right now filling in the rest of this?
Yeah, now I understand. Thank you.
Okay, all right. Thank you for asking. If you're not fine, we can go further. But if you've got it now, are you okay if we stop here?
Yeah. Yep. Thank you so much.
You're welcome. Thank you for asking. Does anybody else have any other homework questions? If not, go ahead. Was that a question? If not, then, oh, we are here already. We're going to switch gears a little bit. And we're going to start looking at probability. Oh, Lord, what happened there? Here we go. We're going to start looking at probability. And in probability, I think everybody's heard of probability. Probability is kind of like a measure of the chance of something occurring. However, in chapter 2, we're not going to get to that definition of probability until section 4. The first 3 sections deal with something that's a foundation for probability, and those are counting methods. And so the first 3 sections of the chapter don't even look like probability, because all we are going to do is we're going to look at different problems and see what we need to do to figure out how many possibilities there really are. The first counting method that we're going to look at is something that I call the fundamental counting principle. And well, of course, I think it's fun because I'm a math geek at heart. But I also find that this first assignment, most students find rather easy, because this formula is, there's a couple of intricacies, but it's not really that difficult to apply. To introduce the fundamental counting principle, I'd like to look at an example. And I have to tell you, I'm having a feeling of deja vu because I did this at the end of my night class last night, this exact same problem. So let's say I have Susie Q, Susie Q owns 4 sweaters. And she owns 3 pairs of jeans.
You're going to upload this, right? We don't have to write all this.
Right. I have every class. If you ever go through and look at it and what I upload every once in a while, because I do this for like 3 classes in a row, if you see the wrong note, send me an angry email, or if there's something wrong with what I uploaded, send me an angry email. But I always upload the content of this document as a PDF to Blackboard.
Okay, thanks.
So an outfit is going to consist of 1 sweater and 1 pair of jeans, no layered look. I want to know how many outfits are possible. How many? I apologize. I should have said different outfits. How many outfits can she make?
Sweaters, 3 jeans.
Any ideas?
Would it be 3?
Okay, I'm hearing 3. I heard another answer. What else? Try to picture it. We're looking in her closet and we see 4 sweaters.
Yeah, she has 3.
3 sweaters? No, she has
No,
4.
3 outfits, 3 outfits.
Oh, I think she's got a lot more than that. She's got 4 sweaters, and she's a math geek like me, so there's sweater 1, 2, 3, and 4. And with sweater 1, she could wear the first pair of jeans, the second pair of jeans, or the third pair of jeans. So there's 3 different outfits with sweater 1, right? And in the same way, can she wear any one of the 3 pairs of pants, pardon me, with sweater 2,
So
giving her 3 more outfits. And the same way. So doesn't each sweater have 3 outfits with it? And so I'm hearing people now get it. There are 12 outfits, right?
Well, I was thinking 3 if she, did the laundry. If she's not doing the laundry, I guess, yeah, she got that many outfits.
Does everybody see that there are 12 of them?
Yes.
4 sweaters, each sweater can be worn with each one of the 3 pairs of pants, or 12 outfits. And we get that by multiplying. And so I don't want this page to be too long. Are you guys all right if I turn the page? And I apologize. You can tell from this picture, this is why I teach math and not art. So, all right. So what that fundamental counting principle says is that if you can choose 1 from n objects and 1 from m objects, you have m times n different choices or different combinations. But we're going to multiply. Just like with that first sweater, she could have worn any pair of jeans. So for each sweater, she has 3. So altogether, there are 4 times 3 possibilities. And so for most of this homework, you're going to be multiplying. But we're going to find that sometimes it takes a little bit of thought to see what you multiply. Is everybody ready for another example, or do I need to hold my horses because you're still writing?
It's okay.
I'm ready.
So let's say we have a restaurant that, oh, how do you spell restaurant? Well, pretend that says restaurant. that just serves grilled cheese sandwiches. From the menu, they have 4 types of bread. They have 5 types of cheese. How many different sandwiches can you build if you can only have one type of bread and one kind of cheese?
Four?
4 choices of bread.
How many types of cheese do we have? Just one?
No, this is 5. It looks like an S, but it's a 5.
Oh, okay.
5 cheeses. And what should I do with those numbers?
Multiply them.
So there are
20.
20 different sandwiches. So let's say another example, going back to food, you go to a restaurant. And if you guys ever gone to a restaurant on something like Valentine's Day and they have a very limited menu, but you get to order a full meal for a certain price. And in your options, let's say you can pick from 3 different soups, 10 different main dishes, and then let's say 7 different desserts. How many combinations are possible? Any ideas on how I'm going to get there?
Is it 210?
It is. Can you explain to me how you got there?
Well, I did 3 times 10, which is 30, and then 30 times 7.
And so if we've got more than 2 things that we're choosing from, it just means that we're going to be more than 2 decisions to make, right? We have to decide on the soup, the dinner, and the dessert. And if you guys are at all like me, first you pick the dessert, then you pick the dinner, then you pick the soup. But I digress. Next example is a brain buster. It's a make you think question. Let's say there's a true false quiz. On this quiz, there are 10 questions. You're clueless. So I'm clueless, so I'm going to just guess. Pretend somebody's giving me a history quiz or something. I'm just guessing. Is everybody familiar with the idea like something like a multiple choice quiz or something like a true false? You're not going to leave it blank. No blanks. We're just guessing. We're just doing it randomly. How many different ways can we answer the questions? How many different ways can we answer the quiz?
100.
And where are you getting that?
10 times 10.
10 times 2. 10 times 10, I apologize. Okay, I like the idea of multiplying something by itself, but let's think about this. There are 10 questions, right? And so when I go through and take that quiz, don't I have to make a decision for each question? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I'm making 10 different decisions. And for each of those questions, how many choices do I have?
2.
2. So I have 2 choices for this, this, and 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 this. And doesn't that counting principle tell me to multiply all of those?
Where do we get the 2 from?
True or false?
Ah,
2 answers. It's either true or it's false. And so wouldn't this give me 2 to the 10th? And if I multiply 2 times 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 2, I get something like 1,024 ways.
Oh, wow.
So if I were just guessing on this true false quiz, there are 1,024 ways that I can answer it. And you guys are right, only one of them, they're all going to be right. So there's 1,023 ways I can mess things up, right? So let's change it.
On a problem like this, are we allowed to use our calculator?
Yeah.
Okay.
Yeah, for anything in this class, you can use your calculator. So let's say instead we have a multiple choice test. Let's say it has 5 questions. Each has 4 choices. How many ways can we answer? So how many decisions are we making?
4.
4?
Are we making 4 decisions, or do we have 4 things to pick from?
5.
5.
With each question, right? 1, 2, 3, 4, 5. And for each question, I have 4 things to pick from.
So it's 5 to the 4th power.
Oh, well, let's look at it. What number are we multiplying? I think
4
it's
times 4 times 4.
so it's 4 to the 5th. So
Uh,
right idea, but you juxtapose the numbers. We're taking the number 4, multiplying it 5 times. So 264 times 4 is, anybody got a calculator to help me out, or are you guys gonna make me do this in my head?
1,024.
Oh, it's the same answer. Okay, 1,024. Well, that was pretty cool. They don't all give you the same answer.
I actually thought I was wrong because I got the same answer as the first one.
Oh, I apologize. I just kind of made that question up as we were going along. It wasn't intentional. It was the same answer. So let's look at phone numbers. If I look at phone numbers with the area code. Phone numbers with an area code, there are 10 numbers. Did anybody ever notice that the area code can't start with 0 or 1? Because if we dial 0 first, it's not going to take us anywhere. That's the old-fashioned operator thing. If we dial 1 first, they're going to think it's a long-distance call, no matter what the area code is. In the same way, the phone number itself can't start with 0 or 1. Did you guys ever notice that phone numbers and area codes never start with 0 or 1?
Yeah.
Yeah. How many are possible? How many phone numbers possible? So let's see, we've got 3 numbers for the area code and 1, 2, 3, 1, 2, 3, 4 for the phone number. This first can't be a 0 or a 1. How many digits are there left to pick from? It could be 3, 4, 5, 6, 7, 8, 9, or 10. Aren't there 8 choices there? This one can't be a 0 or a 1, so there are 8 choices there. But all the others can be anything. And so if it can be a 0, a 1, up to 9, is everybody all right? That means there's 10 possibilities for all of those other ones.
Yeah.
And the counting principle tells me to multiply all of those. And so when I do that multiplication, 8 times 8 is 64. And then we've got 1, 2, 3, 4, 5, 6, 7, 8 factors of 10, which is like throwing 8 zeros at the end of the number. And so what is that? hundreds, thousands, millions, billions, 6,400,000,000 different phone numbers possible. How cool is that?
Hmm.
Let's look at one more example. I'm thinking this might be getting long, so I'm going to add a page. Let's look at license plates. License plates, I just want not commercial vehicles, just like regular cars, and I'm not including vanity plates. And I guess I'm going to only go by New York State. Do any of you guys have cars without with regular license plates? What do you have? You have 3 letters and 4 numbers?
Yeah.
I remember once we got the new license plate and the letters were CGZ, and I remembered it because we put it on. We had 2 cars, like a minivan and a sports car, and CDZ was Crisco Zoom, and the other car was CDB, and that was the minivan, and it was Chris's damn bus. But so anyways, 3 letters and 4 numbers. 1, 2, 3 letters, 1, 2, 3, 4 numbers. The question is, how many are there possible? How many plates? So these first 3 have to be letters. How many letters are there to choose from?
24.
Close. I'm thinking there's 26 in the alphabet.
Oh, 26.
Yeah. And letters can repeat in a license plate. So each of those, there are 26 choices. The numbers can be anything. They can be anything from 0 through 9. So there's 10 choices for each of those. And my counting principle tells me to multiply. And so when you multiply that out, what do you get? Anybody getting 17576 and then 4 zeros?
Yep.
Yeah.
Put the commas in. There are 175,760,000 different license plates available. Does it make sense if they need more than that? All they have to do is add another letter and we'll have 26 times as many, right? So, but you see how that fundamental counting principle tells me I've got to figure out how many decisions I'm making. I've got to figure out how many choices I have for each, and then I multiply. Whether it's license plates or phone numbers or answering a quiz, something like answering a quiz, each question is a different decision. And so we have to figure out how many choices we have for each, and we're going to multiply. But some of the ones on the homework are like the restaurant and the cheese and Susie Q's outfits, where it's a little bit more straightforward what you multiply. But this general idea of this fundamental counting principle, how is it?
Not bad.
Not bad. We've got like 4 minutes left, and the next place that we're going is going to take a whole bunch more than 4 minutes to pick up. So let's stop here, which is actually where I stopped last night with my night class. So let me make note of that fact. And does anybody have questions on anything that we've done?
No.
Okay, then I am going to stop sharing my screen and I'm going to stop recording.